Okay, so now we're going to get into talking about volume. So the definition of volume is the number of cubic units contained in a solid's interior. Okay, so basically like volume is filling something up. Okay, so some things that we need to remember is the area formula for a rectangle or square is area is equal to lowercase b times h, which stands for base times height. Triangle area equals 1/2 lowercase b times h. Trapezoid area is equal to b sub 1 plus b sub 2 all over 2 times h. And circle is area equals pi r squared. Okay, so now that we know those things, and we have them written down, we can come back to them. Something I want to talk about next is the volume of a prism. Okay, so the volume of a prism is capital V equals, now notice it's capital B times H, where capital B is the area of the base. Okay, it's the area formula of the base, then H is still just the height. Okay, so let's look at our example here. So this is a prism. Okay, remember prisms separate their bases by by rectangles. Sorry, I couldn't think of that word. So you know that you're going to have rectangles, okay, which you could have all rectangles, but you can also have other shapes in there as well. So capital B times H, your base in this case is the triangle, okay? So the triangle is, we're going to come down here, we're going to do the area formula for a triangle. So capital B is equal to 1/2, the base is 3, and the height of the triangle is 4. So 1/2 of 12 is 6. So capital B is equal to 6. Now, whenever you're talking about H as in the height of the prism, okay, something I want you to come back up here and make a note of is the distance between the bases. Okay, that'll help you remember which height to use where. Okay, so the height between the two triangles here, or the distance between the two triangles, which are our base, would be 2. So 6 times 2, okay, which would leave me with 12, and it is centimeters, and volume is cubed because area was already squared. Then we're multiplying it again, so that makes it cubed. So volume is equal to 12 centimeters cubed. Okay. Now on this one, okay, my base is a trapezoid. So capital B is going to be base 1 is 6, base 2 is 14, divided by 2 times the height of the trapezoid it's showing me is 3. So that would be 20 divided by 2 times 3, which is 10 times 3, which is 30. So still on part B, your volume is equal to capital B times H. We just found that capital B was 30. The height, or the distance between your two trapezoids, is 5. So your final answer is 150 centimeters cubed. Okay. Next page. Okay. I like to think of this being as the exact same formula, capital B times H. Okay, the only difference is with a cylinder, your capital B, or your volume, is always, or your base is always a circle. So your capital B is always going to be equal to pi r squared. Okay, so that's why they also show you this pi r squared H, but it's one less thing to remember. Just ask yourself, what is the base of a cylinder? Well, the base is a circle, okay? And that kind of fills in all of that unnecessary extra information, in my opinion, okay? So in part A, I'm going to come down here and I'm going to do capital B. it is pi times 9 squared. Okay, and you can just make that one 81 pi. You can leave it in terms of pi if you would like. If you don't like that, you can make it into a decimal as well. So part A, volume is equal to base times height. We just found that the base was 81 pi, and the height, or the distance between your two circles, is 6. So that's 6, which makes it 486 pi. Now go ahead and multiply this out to get 1,526.81 feet cubed. Okay, so there's your final answer there. Part B, same thing again. Volume is equal to capital B times H. Come down here, let's figure out what capital B is. So it is pi times the radius is 4 squared, so that is 16 pi. So you get 16 pi times the distance between the two circles is 7. Okay, and that would give you 112 pi. Go ahead and multiply that out, and you get approximately 351.86 centimeters cubed. Okay, and let's go ahead and come back and we'll make this approximately equal to as well. That was my mistake. Okay, all right, vocabulary, density. Density is the amount of matter that an object has in a given unit of volume. Okay, so density, you may have heard of this before in science. Okay, science and math are very closely related. You use math to do a lot of science. Okay, so it says different materials have different densities. So density can be used to distinguish between materials that look similar. For example, table salt and sugar look alike. However, table salt has a density of 2.16 grams per cubic centimeter, while sugar has a density of 1.58 grams per cubic centimeter. Okay, so if you turn the page, it says the diagram shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. Find the mass of the standard gold bar to the nearest gram. Okay, so part 1, okay, we need to convert, okay, because it's giving us this in per cubic centimeter, and, per cubic centimeter, and we need to find what inches are in centimeters, okay? So 7 inches, there are 2.54 centimeters per every 1 inch. So you just multiply 7 times 2.54 and you get 17.78 centimeters. So on this one, I'm going to write 17.78 centimeters. And then you're going to keep going, doing the same thing, 3.625 times 2.54. And that would give me 9.2075 centimeters. 9.2075 centimeters, and then 1.75 times 2.54 is 4.445 centimeters. So again, write that over here, 4.445 centimeters. Okay, now that I know that, I can find the volume. Okay, and on this one, whenever it's a rectangular prism, okay, I do kind of let you cheat. Okay, you can just do base times height times length. Okay, just basically you multiply all 3 together, because whenever you do the base, this base, and then you multiply it, so you find the area of this base would be 3.6 times 2.5. 9.2075 times 4.445, then you would just turn around and multiply it again by the 17.78. So it's okay if you just squish all of that into one. I think that's okay whenever it's a rectangular prism. When it's any other shape, I would not do that, and I would find what your area of your base is first. Okay, I think it's just simpler. So whenever you multiply all of that together, you get 727.69 centimeters cubed. Okay, in step 3 then, okay, it tells us that the gold bar has a density of 19.3, and we need to find the mass. Okay, so remember back here, density is equal to mass over volume. So density is equal to mass over volume. So it tells us that the density is 19.3 equals the mass is what we are trying to find. So that is X over the volume is what we just found, 727.69. Okay, multiply both sides by this 727, and you'll get that X is equal to 14,044 grams. Okay, so lots of different things in here. You got conversions, you've got volume, and you have density. Okay, good problem there. All right, last one here is using volumes of prisms and cylinders. It says you are building a rectangular chest. You want the length to be 6 feet, the width to be 4 feet, and the volume to be 72 cubic feet. What should the height be? Okay, so you know that the base is 6 times 4, which is 24. Okay, and you're just trying to figure out what the height should be. Okay, so the volume it tells you is 72. The base we found out was 24, and we're looking for the height. So divide by 24 on both sides, and you get that the height should be 3 feet. Okay, and that is all that you should need for your notes. Let me know if you have any questions.